Swayam Prabha. Digital India. Educated India.
Now we'll see how to carry out mesh analysis for circuits which have a current controlled voltage source. What I've done is I've taken the same circuit as before but replaced the second voltage source by a current controlled voltage source, Rm times Ix, and Ix is this current. Okay. Now clearly this controlled voltage source is in the second mesh and it's going to affect the equation only for the second mesh. Okay. So for the first mesh, the equation is the same as what we had earlier, that is I1 times R11 plus R12 plus R13 minus I2 times R12 minus I3 times R13 equals V1. Okay. Now for the second mesh, the independent voltage source in the second mesh is 0. So on the right hand side we'll just have 0. On the left hand side, if I ignore the control source, okay, I will have I2 times R12 plus R22 plus R23 minus I3 times R23. Okay, these are the contributions from the resistors, and I'll also have I1 times minus R12. Okay, so these are the contributions from the resistors in the second mesh. Okay. So this is what I have, but this is not complete because I have to also additionally take this voltage drop, which is Rm times Ix. Okay, so on the left hand side I'll have plus Rm times Ix. Now Ix, I don't want to use another variable here. I know that this Ix here in this branch equals I1 minus I3. Okay, so instead of Ix, we have Ix to be I1 minus I3. So we will have plus Rm times I1 minus I3. So if I rearrange it while grouping the current variables, I have I1 minus R12 plus Rm plus I2 times R12 plus R22 plus R23 minus I3 times R23 plus Rm. Okay, so this is what I'll have, and you see that this Rm, because Ix is here and Ix equals I1 minus I3, Rm adds to the coefficient of I1 and subtracts from the coefficient of I3. Okay, and for mesh number 3 nothing has changed. I just have I1 R13 minus I2 R23 plus I3 times R13 plus R23 plus R33 to be equal to 0. Okay. So if I put this in matrix form, I'll have R11 plus R12 plus R13 minus R12 minus R13. Here I'll have minus R12 plus Rm, which is the contribution of the current controlled voltage source, then R12 plus R22 plus R23 and minus R23 minus Rm. Okay, and the third one is the same as before, minus R13 minus R23 R13 plus R23 plus R33 I1, I2 and I3. Okay, and this whole thing equals V1, 0, 0. So these are the mesh analysis equations, and this is analogous to the case of nodal analysis with a voltage controlled current source. Okay, what we have here is mesh analysis with a current controlled voltage source, and that's analogous to nodal analysis with a voltage controlled voltage source. You can write the three node equations. Now the matrix becomes asymmetric. As you can see, this element is not equal to that element. Okay.